How many of you have actually spent time in, I call them the NGSS because the Nevada standards are the NGSS, right? We've just kind of taken them. How many of you have spent time in the standards? Not looking at the standard as it's approached to your curriculum material, but actually spent time in the standard, looking at the standard. Not many? A little bit? Go ahead, comment.
Yeah, in college we were looking at them because I think when I was in school they were starting to bring in NGSS, yeah. But I didn't understand because I wasn't teaching, so it didn't make sense, yeah. So now I'm like starting to make
Put it all
sense.
together.
Yeah.
Right. But as a teacher, have you had extensive opportunities to dig in? Okay, right. So just briefly, and then I'm going to let you. There are 4 domains across K-12: physical science, life science, earth and space science, and engineering, technology, and application of science. So when we look at how the NGSS is set up, when you physically look at the document, at the top is the performance expectation. What is a performance expectation?
Of the students.
What the student should be able to do with this, right? So that performance expectation integrates those 3 dimensions of the disciplinary core ideas, the practices, and the cross-cutting concepts. I want to pause for just a minute, and I want us to think about, we talk about the power of integrating listening, speaking, reading, and writing for our kids, right? What is the power of the cross-cutting concepts? We look at them being patterns, cause and effect, scale, proportions, systems, energy and matter, structure and function, stability and change. When we look at the fact that those cut across, when we look at the fact that NGSS and like on the document talks about the interrelationship with the Common Core State Standards or your Nevada standards, right? What's the power in that for our kids? What's an opportunity there? When you're thinking about how these cut across in this integration, why is that powerful for our kids?
They're using the language throughout the whole day.
Absolutely. It's that multiple opportunities, right? And they're seeing it not as this is science and only science, and I only get to use this during science time. Oh, my goodness. We have patterns in math, patterns in language arts. Cool. We can do models here, and we can, right? So that's an opportunity for our kids if we're intentional about it, okay? So these are the pieces that you'll see when you look at the standards. So you'll see the performance expectation at the top, and then you'll see this division of disciplinary core ideas and cross-cutting concepts and the practices, so that you can see how they all come together, okay? So what I want you to do now, you can do it in one of 2 ways, or 3. You can go straight to the NGSS website. Gloria sent you the link to the Nevada standards, or there's an app that you can download if you want to have your standards right here with you at all times. So I want you to spend some time, and what I want you to start with is you have a choice. I want you to find the standard for the lesson you submitted. I want you to find the standard for a lesson you're going to teach. Okay, what's a better use of your time? To think about a standard upcoming or being reflective of what you've already done. And I want you to look at that science standard and I want you to read it. I want you to read the performance expectation. I want you to look at those 3 dimensions across, and I want you to gain a really solid understanding of what the science of that standard is, okay? I want you to think about the thinking and language that's needed to get there. And then I want you, if you want to spend some time reflecting on the 3 dimensions? And are you spending time in the 3 dimensions?
Yes, students who demonstrate understanding can communicate solutions that will reduce the impact of humans on land, water, air, and or other living things in the local environment.
So they have to communicate the impact.
They have to communicate the
Impact.
impact, right? Not what is it to recycle?
Mhm.
What does it mean to recycle? That recycling is good. It's communicating the impact, right? So how powerful to actually look at the standard
Mhm.
to make sure that the materials that we're using and have been provided don't just align to the topic, right? But get the students to those performance expectations, not definitions, performance expectations. Good observation. Gloria?
And also it said that they have to provide the solution to the problem, so. So recycling, it can be thought that it's one solution to the problem.
Exactly, and thinking about what's the problem first that needs to be solved. Good. What else did you notice? Thank you, Erica, for jumping in with that one. What else did you notice? That was a really good observation. Are they overwhelming?
So I kind of like how under each like standards, like I actually didn't notice it before because I just look at like the topic arrangements and then just kind of like look at the standards. But underneath it, you can like hit the science and engineering practices that relate to it and disciplinary core ideas that relate to it. So like you can see that like with the, you know, for example, the environment one, you can designs can be conveyed through sketches, drawing, or physical models. So you can see how you can integrate like the engineering standard. And is there ELA? Yeah, is it ELA? There's ELA in here. Oh yeah, there's ELA. Yeah, WK2, use a combination. So it kind of, I just noticed that, even though I've had this app for a while, because I just look at like the topic
There's a lot in
arrangement.
there, yeah.
Yeah, there's a lot in there. You can see where it's, where it hits other standards.
Absolutely, right. So you can see how you can integrate part of the science in your English language arts, right? You can integrate it across your day. Okay, good. Anything else? Okay. All right, so we're gonna keep moving. We're not gonna leave the standards. So what I want us to think about, as we talked about that science is new for all of our students, right? For a lot of our students, science is new. I want us to really dig into the practices, okay? And I want us to think about the practices from a standpoint of not resources, not as a barrier, right? But really kind of thinking about our practices in this integration with the ideas. Because what a lot of us talked about was this hands-on piece is where the power lies, right? We talked about how the hands-on visual nature of science is where the power is powerful. It's not only where the power is. So what I want us to do, particularly, I want you to watch this next video, and I think these are really good examples that give us multiple ways to think about our practice. As you watch, I want you to think about the practices being similar, or are they contradictory and make you think about some things as it relates to what we know about second language acquisition. Okay. I want you to think about what your next step is in your development, particularly in the practices, right? Not the disciplinary core ideas, not the cross-cutting concepts. What's your next step in terms of practices? I want you to think about an upcoming lesson and where can kids experience science in their community, okay? Again, pretty broad, pretty open, because I think we're all in different places with our science practice, but I think this gives us a good starting place to think about what we want to do different, Okay, what's our next day? All right, questions?